All right, today we're going to look at section 3.8 or 3-8, which is given zeros, find the polynomial. All right, so if you remember a couple days ago, we actually did example 1, so I'm going to skip that one, and we're going to jump right to the second part of example 1. So we notice that we have two x-intercepts. So we know our equation has to look something like x plus 2, because this x-intercept is negative 2. And this guy's at 1, so it's going to be x minus 1. These both, if you notice, cross through the graph, so neither of these have to be squared. Remember, if it bounces, you do have to have a squared. And then we always went and we put that a value in front, because we're not sure. We do see that this graph opens down. So one of the things we have to be careful with is we know that that a value is going to be negative. And one of the things we notice too is this has one turn here, two turns here, and a third turn there. So if you remember, the maximum number of turns is always equal to the degree minus 1. So because we have, again, one turn up here, two turns here, and a third turn there, we know that we have 3 turns, and that's got to be the degree minus 1. So that means the degree has to be 4. So we have two options. We know that the exponents on these these factors have to be odd. So they have to add up to 4. So I could either go 1 and 3, 3 and 1. It doesn't matter. I'm going to go ahead and put 3 on the first one and 1 on the second one. There's also another option, is that's to flip it and put 1 on the first and 3 on the second. There are definitely multiple equations that could end up with this graph. All right, so then the other thing we need to do is we need to find that a value. And remember, to find that a value, we do that by using the y-intercept. So I know my y-intercept for this point is 0, 2. My x value is 0. My y value is 2. So I'm going to go ahead to this equation. I'm going to plug in 2 for y. I'm going to leave the a where it is. And I'm going to plug in zeros for all of the x's. All right, if I keep doing the math and simplifying here, I've got 0 plus 2 to the third power. So that gives me 8. And then 0 minus 1 to the first gives me a negative 1 times that a in front. So I've got 2 equals negative 8a. And if I divide both sides by negative 8, that gives me the a value of negative 1/4. All right, so my final equation is y equals, I'm just going to take this a value right here and I'm going to plug it in up to that equation. So it's y equals negative 1/4 and then x plus 2 cubed and x minus 1 to the first power. We don't have to put the 1 there. But again, taking a look at that degree is definitely something we want to consider when we are writing this equation. It has to at least be a degree of 4. All right, so one of the things that we need to talk about is we need to talk about zeros. So anytime we have an imaginary zero, so like this one, we have negative 4i. We also know that we have the opposite of that. We're also going to have 4i as a 0. If you think about the quadratic formula, when we do the quadratic formula, we get something like negative 3 plus or minus, I don't know, I root 2 over 4, if we were to do the quadratic formula. So we always end up with that plus or minus in between. So that means anytime we have an imaginary, they have to come in pairs. Okay, so what the rule says is that if a plus bi is an imaginary, so is a minus bi. So that comes from that plus or minus in the quadratic formula. We always have a plus and a minus, whatever that imaginary part is. So it says, given the degree of the polynomial in the zeros, find the remaining zeros. So we know that this one had to be degree 4. All right, so that means I have to have 4 zeros. So I've got 1, 2, 3. Now I have 4 zeros. So my polynomial would have to be something like this. And it says don't multiply it out yet. It's got to be x minus 2 for the 0 of 2. It's got to be x minus 3 for the 0 of 3. It's got to be x plus 4i for the 0 of negative 4i. And then x minus 4i for the last one. All right, taking a look at the next one. Okay, it says degree 5. So we need 5 zeros. Well, you can see that we only see 3. So remember, if we have positive 2i, that means we also have negative 2i. If we have 2 plus I, that also means we have 2 minus I. So there's my 5 zeros. So if I were to write this polynomial out, because of the 1, I get x minus 1. Because of the plus 2i, I get x minus 2i. Because of the minus 2, I get x plus 2i. I'm going to run out of room here, so I'm just going to put them below. Remember the 2 minus I, it's always x minus the 0. So we also have x minus, and then in parentheses 2 plus I, like we did yesterday. And then we also have x minus in parentheses 2 minus I. So there are my 5 factors. I've got the x minus 1, x minus 2i, x plus 2i, and then I've got these last two for the 2 minus and 2 plus I. And those are my 5 factors because my degree is 5. All right, so the next problem say, find the polynomial with real coefficients in standard form that have a degree given, and then given the zeros. And this time it says, be sure to multiply it out. So let's take a look at example A. This one's nice. We have 3 zeros. It is degree 3. None of those are imaginary, so we don't have to come up with any extras. So my parentheses for this polynomial are going to be x minus 1, x plus 2, and x plus 4. All right, now we have to multiply this out. So the order that we multiply, remember, doesn't matter. Since I have them in order here, these two, there's really nothing that's easy to multiply. I'm going to multiply the first two together. So here I get x squared, I get a plus 2x, I get a minus 1x, and I get a minus 2. So when I multiply those out, I get x squared plus 1x, right? That right there gives me 1x minus 2. Now, I've got to continue to multiply that by the x plus 4. I'm going to go ahead and put the x plus 4 out in front. Remember, the order that we multiply doesn't matter. And now we're just going to distribute again. I've got to distribute that x to all 3 parts, and then I've got to distribute the 4 to all 3 parts. So x times x squared is x cubed. X times x is x squared. Be careful, don't make it 2x. X times negative 2 is negative 2x. Now distribute the 4, so I get plus 4x squared plus 4x, and then minus 8. Our last step is to simplify. So I've got just an x to the third, so there's nothing there, but that gives me my degree 3. I've got a 1x squared and a 4x squared, so that gives me 5x squared. Okay, I've got a minus 2x and a plus 4x, so that gives me plus 2x. And then at the end, I've got that minus 8. So basically what we're doing right here is we're going backwards, right? The last couple days, we've started with a polynomial that looks like this, and we've ended up trying to find it in factored form and finding the zeros. Now we're just going the opposite direction. I think it's a little bit easier than what we've been doing. It's just a matter of distributing. All right, taking a look at the next one, it says we have a degree of 3, which means we need 3 parentheses. You notice that I only give you 2, so there's a problem, but remember imaginaries come in pairs. So I know positive 2i is also a 0. So when I go to write my factors, I know I've got x plus 1, I've got x plus 2i, and I've got x minus 2i from the positive one that we just added in. All right, so now when we multiply, you definitely want to multiply the imaginaries together first. All right, so I've got x times x, which is x squared. I've got x times negative 2i, which is negative 2i and an x. Now I've got 2i times x, which is a positive 2ix. And then lastly, I've got a negative 4i squared. Now, one of the things we haven't talked about yet, I don't think, is I squared. So we know that I is the square root of negative 1. Okay, so if I go through and I square that, I squared, the root cancels the squared, is equal to negative 1. So anytime we see I squared, we're just going to substitute in a negative 1. All right, so I've got x squared. My 2ix and my negative 2ix cancel, right? Those add up to 0. And then I have a negative 4 times a negative 1, so that turns into x squared plus 4. If you think about solving that, if I were to set that equal to 0, I would move the 4 over. It would be x squared equals negative 4. And then if I square rooted both sides, I would get plus or minus 2i. So that should make sense that that's the polynomial we get when we multiply that out. So I've got to take that polynomial, and I can't forget that I need an x to the third, so I still have to multiply it by that x minus or x plus 1. So here I get x to the third. Here I get 4x. When I distribute the 1, I get plus 1x squared, or just x squared. And then the last one I get plus 4. So I want to make sure I write that polynomial in order, descending order. So it's x to the third. a positive 1x squared, I don't know why I put the 1 in front, but plus x squared, plus 4x, and plus 4. So again, that looks like all of the problems on our homework for the last few days, and then we would just go backwards and we would find the zeros. All right, so it gets a little bit harder as your imaginaries get a little bit more confusing. So if you take a look at the next one, it says degree 3. So notice we only have 2 zeros, so that means we're missing a 2 minus I. So when I put the polynomial together, since we have 3, that means we've got an x minus 3. Since we've got 2 plus I, remember it's always x minus, and then in parentheses, 2 plus I. And then the last one is x minus, in parentheses, 2 minus I. All right, just like I mentioned before, we are going to want to multiply the i's together first and then come back to that x minus 3 in the beginning. So before we do that, we first have to distribute. So I want to distribute the negative sign. So this becomes x minus 2 and then minus I. And then this one becomes x minus 2 plus I. That's going to make it easier for us to distribute. So we get x times x is x squared. X times negative 2 is negative 2x. X times I is positive ix. I'm going to switch colors. Now distribute the negative 2. So negative 2 times x is negative 2x. Negative 2 times 2 is positive 4. Negative 2 times I is negative 2i. All right, and then finally, we've got to distribute that negative I to everything. So that gives me negative ix. That gives me positive 2i. And then at the end, I get negative I times I, which is negative I squared. So we end up with 9 different terms, but nice things happen. If you notice here, I've got a positive ix, and then I've got a negative ix. Those two cancel out or add up to 0. I've got a negative 2i and a positive 2i. So if you look right now, all of my i's have gone away with the exception of this minus I squared. Well, remember, I squared is negative 1, so if I do minus negative 1, that turns into a plus 1. So when I look at what I've got left, I've got x squared. I've got a negative 2x and a negative 2x, which is a negative 4x. And then I've got a plus 4 and a plus 1, so that's plus 5. All right, unfortunately, we're not done yet. We got to bring down that x minus 3. And we've got to distribute one more time. So we get really good at foiling or distributing when we do these problems. So I've got to distribute the x to everything. So that gives me x cubed, negative 4x squared, and a positive 5x. Now distribute that negative 3 to everything. So that gives me a negative 3x squared, careful, a positive 12x, and a negative 15. So my final polynomial that gives me the zeros that we had up above is x to the third. I've got a negative 4x squared and a negative 3, so that's negative 7x squared. I got a 5 and a 12x, so that gives me a 17x. And I've got that minus 15 at the end. So there is my polynomial. All right, we're going to do one more, which is this one up here. Now it says we have 4, right? So there's 4. It says we have negative 1 with a multiplicity of 2. So what does multiplicity mean? Remember, that's if it's negative 1, we know the parenthesis is x plus 1. And we just have 2 of them. So there's 2 of the zeros. We also have negative 2i, which means we also have positive 2i. So my other parentheses are going to be x plus 2i for the negative 2i and x minus 2i for the positive 2i. All right, so again, I always like to multiply the i's first because the I squareds end up going away, so it's nice. I've got x times x, which is x squared. I've got x times 2i, negative 2i, which is negative 2ix. Now I've got the 2 in the middle, which gives me my positive 2ix, which are going to cancel out. And then I've got my negative 4i squared. Again, we talked about I squared becomes negative 1, so it's negative 4 times negative 1. These guys cancel out, so we get x squared plus 4. Now, the downside is we still have more. We still have an x plus 1 and another x plus 1. So I'm going to multiply those together first because I think that's a little bit easier. So I've got x squared. On the outside, I've got plus 1x. On the inside, I've got plus 1x. And then I've got plus 1. So we've got x squared plus 2x plus 1, and then we've got to multiply that by x squared plus 4. Now, I don't like the x squared plus 4 there, so I'm going to go ahead and I'm going to move that in the front. So then we have to FOIL those out as well. All right, so our last step then is to multiply. So x squared and x squared is x to the 4th plus 2x to the 3rd plus 1x squared, or just x squared. Then when we distribute the 4, we get 4x squared. We get 8x, and then a plus 4. So our last step for this one, and notice we do have a polynomial that has a degree of 4. So we've got x to the 4th. We've got a 2x cubed, and there's nothing else, so there's a 2x cubed. We got a 1x squared and a 4x squared, so that gives me 5x squared. And then I've got an 8x and a 4. All right, so that's it for today.